I bet, guys, today we're back. Today we're going to be talking about Pourbaix diagrams and passivation zones. We personally haven't learned it in school yet, but I just watched a couple of YouTube videos and did some Googling, and I think it's pretty easy to learn. So, Pourbaix diagrams, let me pull it up. Visual. It's basically a map that shows the most stable species in solutions as a function of pH and voltage. Okay, so pH is on this logarithmic scale to fit on the graph better, and voltage, electrochemical potential, is on this side. Yeah. So yeah, it's really easy. It's just at lower pH, copper, when it's a metal, it's more stable. So if it goes outside of these enclosed area, it'll get more unstable. And then higher up on the pH, Cu2 plus is stable, right? And these equilibrium lines basically just separate where different species are stable or not. This whole graph, again, it depends on concentration, but this is just the main uh, kind of what corrosion engineers use most of the time, because we use this a lot in corrosion. So what are these blue lines? These blue lines are basically it shows if voltage is above or below it. It means that the water is unstable. Water is unstable, and it'll generate H plus ions. So yeah, that's not good. And these are, yeah, so everything is dipped in water, by the way. So yeah. So what can we do to, like, if we don't, let's say if we don't want this region, we want to go up to this region or something like that. For pH, it's really easy. We can either add like strong acids or strong bases to get what we want, right? And then for voltage, we can throw electrolyte to kind of dictate which voltage we want, or we can use um oxidizing and reducing agents. So that's pretty cool. Another cool thing we can use this for is if we like superimpose this image, two different maps. So this is the copper one, and if we put an iron one on top, and the overlap of the regions where we can tell if things don't really react well with each other, that's kind of cool. And okay, so passivation zone. What is passivation zone? It's basically the specific region of pH that is thermodynamically unstable, meaning it wants to corrode, but instead it dissolves away into a solution, and it forms, like what I mentioned in previous videos, a thin solid oxide layer as an invisible shield that separates the underlying metal from the corrosion environment. That's exactly what we want. That's literally exactly what we want in corrosion. We want that thin oxide layer that just protects that underlying metal underneath, right? So this is the region where it is. So corrosion scientists all the time, they always want to get our stuff into this region. So this is by either um, dialing up the pH, because as we know from last video, acidic pH isn't that good, or we dial up the voltage. The the copper metal solid, um, copper metals, this is just the immunity zone. Basically, when copper is stable and it won't corrode, if we add more voltage up here and keep the low pH, this is where Cu2 plus kind of gives off two electrons, and passing the horizontal line, copper oxidizes. So I guess this is the danger zone. You don't really want to be in this zone right here. These vertical lines and horizontal lines. So vertical line means around, like, let's say like 4.5 pH. These two can kind of coexist with each other, right? That's a little slimmer of pH. And then here for the voltage line too, at let's say 0.2, they can coexist here and they'll both be stable. So yeah, once again, this is just a map that shows the different compositions, how it's stable, and corrosion scientists use this a lot to see kind of where we want to have materials to protect against water and oxygen. So thank you guys for listening to my video. I learned this in like 30 minutes. Hopefully I did a good job. I don't think it was that hard to understand.